All right, so today's lesson, as you see right here, is an equation of a circle. So we've done equations of lines. We've touched very, very briefly on a curved line. What was that curved line called that we did? A parabola, right? So we did that. I think we did a did we do a cubic function where we had x cubed? We didn't. We did a sideways one, didn't we? Yeah. So we didn't really hit on that too much, okay? But most of it was a straight line. Just took a quiz today on a straight line. So now what we're going to do is an equation of a circle. Go. All right, so let's do the definition first. Right when we start. All right, that's all right. All right, let's do the definition first. Okay, so let's write this down. Okay, so the definition of a circle. Let's see what a circle is. So what would you say normally? You just say a circle is this round thing, right? But they get a little bit more definitive on it. It's a set of all points. Let's write it down. Not all points, it's a set of points. You writing this down? A lot of people talking. In the XY plane. So far, everything we've done is in the XY plane. So, you just kind of figure that it is. But there are maths where it's not always in the XY plane. There's the XYZ plane, right? Third dimension, right? Three-dimensional stuff. We're just doing two-dimensional stuff. That's the XY plane. Okay, it's like the XY axis thing, right? That are a fixed distance. That are a fixed distance. I need to write this down. Fixed distance. And that fixed distance, we use the letter R. I'll put that in parentheses, or not parentheses, but quotations. Okay, it's a fixed distance R. That's what we call that fixed distance from a fixed point. From a fixed point, and we give that fixed point a certain letters. We call that certain point HK. Now, why do you think we call that fixed distance? Now, think about what it is. It's a set of points in a plane, okay? It's just on a piece of paper, basically, okay? It's a set of points that are a fixed distance away from a fixed point. So here's a point, right? Here's a certain distance. It's a set of all points. It's that same distance away from that point. So let's think about it. For those watching online, I got my fingers up, okay? One finger for one point, one finger for another point. And then what I can do is that's a fixed distance, R, whatever that is. Well, what if, is there another point it's the same distance from here? Sure, like right here, right? Same distance, as long as I didn't move it closer or further away. Then here, then here, then here, then here. What's that eventually make if I do all those points? That's a circle, isn't it? So what do you think we call that R? It's R for a reason. It's the radius, that's right. So the R is the radius. And the HK, that fixed point, right? Remember that fixed point right here? Then you had the distance, and that distance is the same all around it. What do you think we call that fixed point in the middle of the circle? The center of the circle, that's right. So the HK represents the center of the circle, okay? That's why I wanted to write that definition down. Sometimes, students don't really care what the definition is. I get it. So sometimes it's just a waste of time to go through definitions. But I don't think this is a waste of time. I think this is pretty important, okay? Because it really just sums up what a circle is. That's what a definition does, isn't it? All right. So let's scooch that up a little bit. And let's draw us a circle. Look at that. It just happened to have a little graph there. Just happened to. And what I'm going to do... let's do this first. Let's put a point anywhere. It doesn't have to be right at the origin. A lot of people think, in a circle, the center of the circle is right at the origin. It doesn't always have to be. Let's go, I don't know, right here. Let's pick any point on that graph. And then what I'm going to do is I'm going to draw a circle. Let's see how I'm going to do this. Oh, I'm going to hit the Shift key to keep it circle. All right, and then take this and move it around like right there. It looks right at the center. And what I'm going to do Just kind of move this about right there. There we go. That looks pretty good. So there's a nice little circle. You see it? And I tried to make it right on the grid mark so it's not like in between the numbers and that kind of thing. So let's talk about that fixed distance. Okay, there's the fixed point. I should say that first. This is the fixed point. So we call it HK. It just represents where the center is. So in this particular one, on this particular graph, where is the center of this circle? We start here, and what do? 1, 2, 3. 1, 2. So what's the HK? What's the center of the circle? It's 3, 2. You with me on that? What about the radius? I made this like perfect so that you could count over and figure out what the radius is. So you start at the center. It's a fixed distance, right? It's all the points that are the same distance from that center point. You with me? It's the same distance from that center point. So if I go from here, like if I went from here to like here on the circle, it'd be hard to count, wouldn't it? Because I'm kind of off the grids a little bit, right? But let's go somewhere where I can really count. Let's start from the center. Let's go to the right. How many do we go? 1, 2, 3, 4. All right, so that lies on the circle. So every point on the circle is the same distance from the center. So if this point is 4 from the center, then everywhere, even right there, even though I can't count exactly where it is because it's like in between those grid marks, that distance from here to here would still be how much? 4. All right, so if I drew a line and I connected them like that, all right, that radius, I'll call it R, equals what? 4. How did I know it's 4? Because I counted over this way and I saw that it was exactly 4. You could count up and it's 4, isn't it? 1, 2, 3, 4. I can count to the left. 1, 2, 3, 4. Count down. 1, 2, 3, 4. Everybody got it? So that's basically the definition in a nutshell. So let's do this without actual points and stuff. Let me see. I got a little thing over here. Let's just do this little. Let's copy that. And let's put that on here. Okay, without all the grid marks. So this is going to be kind of general. What we're going to do is we're going to come up with the equation of the circle. Again, I could sit here and just say, okay, this is the equation of a circle, memorize it, and you guys would feel left out, wouldn't you? Because you're wondering, where does that come from? Where does that equation come from? Would anybody feel left out if we didn't do that? I'm sure you would. All right, so let's do this. Let's extend this just a little bit. Let's see if I can ungroup it. Did that ungroup it? Let me see. Sometimes the keyboard there we go. So what I'm going to do is I'm going to move this down. All right, have fun. Thank you. And I'm going to move this over a little bit, just because I want to put the circle up in this first quadrant right here. So I'm just going to draw any old circle. Let's change the color of it, kind of like that red. Oops. I got to click off of that. There we go. Sorry. There's red. Make that a circle. Let's put a circle. Hit shift, keep it in proportion. Let's put the circle about right there. And I don't know. Let's move it up about like that. There we go. So we got a nice circle. Now let's figure out where the center is and what the radius is. So let's see. Click on it. There we go. And then boom. That's the center right there. Good. So that's pretty good. That's the center of the circle, all right? And let's put a point on the circle itself, anywhere on the circle. It doesn't matter. I could have gone straight across. I could have gone up over here, anywhere. I just put it right here. So what letters did we use to indicate the center of the circle? We just did it with the definition. What was it? HK. Remember those letters, because those letters are going to come into play in our equation of a circle. This point right here is just any point on the circle at all. All right, so what do you think I'll call just any general point? It's got an X and it's got a what? Y. I don't know why that word path comes up all the time. I don't know what I do to make that happen, but anyway, there you go. So let's do this just for fun. Let's put it in a different color, the radius. All right, and then I'm going to connect them like that. Okay, so there's a circle, there's a radius, there's the center, and there's just some arbitrary point on the on the circle, all right? So why am I doing this? Because what I'm going to do is I'm going to come up with an equation of a circle, and I want you to see where it comes from. You're not going to have to do this on a homework. You're not going to have to like figure out where the equation comes from. I just think it's good practice as a math teacher, as much as I possibly can, to show you where these equations come from. They're not just pulled out of the blue, all right? It's not like somebody's walking around thinking, okay, I wonder what the equation of a circle is, and just try a bunch of stuff. It's not that at all, okay? There's a logic to it. So let's take a look. The equation of a circle really comes from the distance of that yellow line right there. The distance of a line. Do you remember having a quiz on the distance? Do you remember the distance formula? Remember what it was? Didn't we have a quiz on it? Yeah? So it's x minus, well, we can do this. We can go x minus x1. It doesn't matter how you do it. Or x1 minus x2. I forget how we did it. Well, I'll just do that, okay? And then plus y minus y1 squared. Remember that thing? Yeah. What we're going to do is we're going to apply it to this. We're going to find the length of that yellow line right there using these letters, okay? It does have an xy in it, but it also has an hk in it, all right? So it's going to be a little bit different than this, but let's put some letters in there. So first of all, the distance. What did we indicate in our definition that our distance of this yellow line is? We gave it a certain letter. What did we give it in the definition? It's r for the radius, okay? So that's going to be r. You okay with that? That means it's the length of that yellow line. That's the d right here. So instead of putting d for distance, we're going to put r because that's the length of that yellow line we're trying to find. Yeah? All right, so I'm going to put a r equals, put that big old square root. Now what we have to do is we have to subtract the points. So I'm just going to I call this the shell, okay? We just kind of put the shell of the equation here, and then we put all the stuff inside here. Now, I got to find, remember it's x1 minus x2 or x minus x1, however you want to say it. It's the two x's subtracted from each other, all right? So I'm going to start with the x and then do the h. So what are my x's? Well, this one is x, and this one is what? H. So what am I going to stick in here? X minus h. You with me? I'm almost there. And this is basically, it's not basically, it's exactly what the equation of a line is. Well, yeah, we're going to do one little thing different. Okay, what's the other part? We subtracted the x's, now let's subtract the y's. So what's that going to be? Y minus k. Very good. See where this is coming from? It comes from the length of the radius. That's what the equation of a line is. It's basically the length of the radius. That's what the equation of a line is. Now this looks kind of ugly with that big old square root there, doesn't it? Right? It just kind of gets in the way. I don't know, it looks like you're real smart with that big old square root, but we're going to get rid of the square root, just make it look a little bit nicer, a little bit prettier than what it looks right here. So how would I get rid of that square root? Everything is under a square root. How can I get rid of a square root? I do what to it? Square it. That's right. So I square both sides, and so what am I going to get? I'm going to get r squared equals x minus h quantity squared plus y minus k, and that quantity is squared. So that right there, let me get my little box. That right there is the equation of a circle. And there you go. That wasn't so hard, was it?
You like figure the radius for the whole circle?
Well, you could write it like this if you wanted to. If you wanted to put that big old square root. It just looks a little neater, a little more compact like this, okay? So what you would have to do, if you put all that stuff in here, you'd have to take the square root anyway to get the radius. But that's how they write it. It just looks a little neater, a little cleaner than what that looks. That's the only thing. Okay, you could use either one, tell you the truth, right? Either one of these would be considered the equation of a circle. This is just what they use to make it look a little prettier, all right? So it's the equation of a what? Circle. You okay on that? All right, so that's where it comes from. Are you going to have to do that on homework? No. Why did I do this? Because I just think it's good for you to know where some of these equations come from. All right, we've done that a bunch of times, haven't we? We did that with slope. We did that with the different forms of the line. We did it with the slope-intercept form and the point-slope form and all that good stuff. So we did it with the equation of a circle. All right, let's do, tell you what, let's grab, oops, I ungrouped it, so I'm going to have to, there we go, copy. All right. What I got, like 7 minutes? Yeah, that's good enough. Let's do this. Let's just make it kind of in between right here. Just push this over a little bit. Let's make another circle, change the color of it. Click on the circle. What is it? Ellipse. There we go. All right, so watch this. I'm going to put a nice circle, center it right here at the origin. All right, so this one is centered at the origin. It doesn't always have to be, but it's nice when it is. It's just centered right there at the origin. And what I'm going to do, I'm going to put this point right here, okay, that's at 1. So if it's a circle, so from the center to here is 1, so what's it going to be up to here? That's going to be 1. What's this going to be? Yeah, it's going to be -1 on the axis, right? And this is going to be what? -1 on the y-axis. Everybody with me on that? Okay, I'm doing this for a reason. We call this thing a unit circle. Unit means 1, okay? And that's why there's 1s here. Yeah.
When we're making, so like, if they give us 4 points and they tell us to graph the circle, how do they know that?
I don't even think they're going to do that. They'll probably give you the equation and ask you to graph the circle. Or you're going to have to eventually you're going to have to come up with the equation, them giving you something else to graph it. Or they could give you the radius in the center and you have to graph it. That wouldn't be that hard. I don't think they're going to give you 4 points. But sometimes when I actually do the graph myself, when I don't have this technology, right, I'm just doing it on paper and pencil, I usually figure out what the one distance is and then just go the same distance on the other ones. That helps me draw the circle a little bit nicer. Okay, good question. All right, so excuse me, what is the radius of the circle? I haven't even drawn it in here, have I? What would it be? It would be from the center, really anywhere on here, right? Okay, but what I'm going to do is I'm just going to take it to here just to make it look a little better for you. All right, it's not exactly straight, but it's good enough. All right, so yeah, what is the radius of this? I heard it. The radius is 1. What's the center of the circle? 0, 0. Good. Okay, so what I want to do is I want to find the equation of a unit circle. So I did all this. I made the radius 1, right? It starts at the origin. Really easy. So let's figure out what the equation of a unit circle is. So what's the basic equation? You probably have it in your notes. Did you write it in your notes? Or did you memorize it? I would write it down several times. Not just a regular circle. Just a regular general circle. What is it? It's r squared equals x minus h squared. What? Plus y minus, what's the letter? K squared. It's a weird looking K. But anyway, that's what it is. So let's put all this stuff in here and see what we get. So what is the r in this particular circle, this unit circle? What is the r? It's 1. And 1 squared is just 1, isn't it? All right. Let's do all this stuff. Plus parentheses. This is my little shell. It's weird looking too. All right. So what's this? It's x minus, what's the h? 0. What's the k? It's also 0, right? That's my hk, my center of my circle. If you want to put it there, hk. Let's make this look a little prettier. 1 equals, what's this? X minus 0 is x, and then it's just what? X squared. What's this? Y squared. They don't usually write it like this. They usually put the 1 over there on the right-hand side. So let's just flip stuff around a little bit. So here it is. Here's the equation of a unit circle. Eventually, this is going to be really important to you. Maybe not today, but eventually it will be. And there it is. That's the equation of a unit circle. What does that mean? And it's an equation of a unit circle that has its center at 0, 0. All right? Because you could have this circle going up here and the radius is still 1. But this is called a unit circle when the center is at the origin at 0, 0. All right? How are we feeling? Let's do one example. I had 2 more examples on my paper, but we're running out of time. And we'll finish this up tomorrow anyway. So let's do one example. This is example 1. How about that? And by the way, that equation that we were given, that equation of a circle, they call that the standard form of the equation of a circle. I should have written that down. They call it the standard form. You're going to learn another form, but this one is called the standard form. Okay, this is the good one. It's easy to use. It's very practical. All right, so that's what it's called. So the example 1 says, write the standard form of the equation of a circle with a radius of 5 and a center of -3, 6. Now, this would be pretty easy to graph, right? If you were to graph it, you'd put a point at negative 3, 6, then you count over 5, count up, count to the left, count down, put your points there, make your circle, easy enough. But we want to find the equation of the circle, the standard form of the equation of a circle with a radius 5 and a point right here. So what is this point? I'm sorry, it's not just a point, it's a center, okay? So this is the center of the circle. So what letter is negative 3? What is that in our equation? That's our h. And what's the 6? Oops, well, I put 6. Why did I put that? K. All right, you with me so far? So let's write the equation down. We have enough time just to do this. X minus h squared. If you keep writing this down over and over, you'll have a better chance of remembering it the more you write it down. If you just watch me write it down and you don't write it down, you're not going to remember it. And you will have to memorize this, okay? You absolutely will have to memorize this. So let's put the stuff in there and write the standard form of the equation of a line. So r is 5. Let's just do this in our head. R squared then would be what? 25 equals, and then now you got to be careful here. It's x minus h. What's the h? It's negative 3. So what's minus a negative 3? What would this eventually be when I simplify it? It'd be plus 3. Okay, make sure you get that. Okay, and then y minus k. What's the k? It's positive 6, but it's a minus because of my equation, right? You got that minus in there. And that's pretty much it. But again, I don't like that number sitting there over there on the left-hand side. I like my x's and y's on the left-hand side. So let's write it nice and pretty. What's it going to be? X plus 3, quantity squared, plus y minus 6, quantity squared, equals 25. I don't have enough time today, but we could graph this as well, all right, if you wanted to. But really, from the information that they gave us at the beginning, that would be the easiest way to graph it. All right, but you could look at this and figure out what the graph is. All right, that's it. No homework today. I'll give you homework tomorrow, and we'll finish up this lesson tomorrow, and I'll give you homework tomorrow.